All right, here we go with the final objective of our unit, which is objective 25, talking about determining the graph from a real world scenario. So, here I first want to talk about varying rates of change. A varying rate of change is a graph that does not have a constant slope. And the fact that it doesn't have a constant slope means that it's got a varying rate of change, right? You can think of slope as a rate of change, and not being constant means it's varying. So I want to take a look at a couple of graphs that have varying rate of change. So a first example would just be a couple of lines here where the slope is not consistent throughout the graph, right? It's very steep here, it's more level here, and then it's very steep again. Another example would be one that just curves. So, you can draw a squiggly graph like that. The slope is very steep here, it kind of levels off, and it just keeps changing. I want to talk about also positive, negative, and zero and undefined slopes. So remember, the definition for a slope is a change in y over change in x. So taking a look at this first example, if I were to just choose any 2 points on this graph, I could choose this one here and choose this one here. The change in y, or how much it's changing vertically, so if we were to go down to the next point, the level of the next point, this would be a negative change in y. And then a change in x, our horizontal change, is positive. So if we have a change in y that's negative over a change in x is positive, a negative over a positive gives us a negative slope. So that is a negative slope. Next up, this one is just straight up. If I were to choose 2 points on this graph, well, the change in y, you can think of it as if we choose our first point to be this one and our second point to be this one, we'd be going up. So our change in y is positive. Our change in x, well, actually, x doesn't change at all. It's the same. We don't move horizontally at all. So our change in x is zero. So we have a positive over zero. Well, anything over zero or divided by zero is undefined. So this one has an undefined slope. Next up, we've got this one here. I'll just choose any 2 points. Our change in y, well, we don't change vertically, right? Our points are exactly horizontal one another. So our change in y is zero. Our change in x to go from one point to the other is positive or negative. Doesn't matter which point you choose. Either way, zero over any number is zero. So this has a zero slope. And last but not least, choose 2 points on this one. Our change in y, or vertical change, is we're going up here. And then our change in x, or our horizontal change, we're going to go right. That's also positive. So you have a positive over a positive means a positive slope. So a quick summary. If you're going from left to right, if the graph is going downward from left to right, then you have a negative slope. If the graph is going upward from left to right, then you have a positive slope. If it's a vertical line, it has an undefined slope. And if it's a horizontal line, it has a zero slope. So now I want to talk about drawing, or sketching really, some of these graphs for some of these scenarios. You are driving your car down the highway at 55 miles per hour. You enter a construction zone and reduce your speed to 40 miles per hour. Draw a curve on the graph below to represent the change in speed. So anytime we're drawing these, so we're going to have this be distance over time. So we're going to put distance up here and time over here. Pretty much for all intents and purposes, time is almost always going to be on the x-axis. So if we're trying to find the change in speed, this is the distance over the time. Time is almost always going to be on the x-axis. So if we were to draw this, well, our speed first is 55 miles per hour. That's pretty fast. That's on the highway. So we're going to say that the slope is pretty high. It's going to have a very steep slope. So we'll just kind of sketch that. There's 55 miles per hour. Then we enter a construction zone and reduce our speed to 40 miles per hour. So now the slope isn't going to be quite as dramatic. It's not going to be quite as steep as this. So right here is the point where we enter the construction zone, and now we can draw in our other slope at 40 miles per hour. And again, that's not as steep as the first because we were driving faster at 55. Let's try a couple more examples. Go ahead and flip the page. Example 3 says you drain water from a pool through two drains. At first you open one drain and the water drains at a speed of 100 gallons per minute. After 5 minutes, you open the second drain and the water begins to drain at a speed of 160 gallons per minute. Draw a curve on the graph below to represent the change in speed. So here, again, this is going to be gallons over time. So how many gallons are drained over a unit time? So again, time is our x-axis. So the first one is it's draining at 100 gallons per minute. So we'll just go ahead and sketch that in, just kind of approximate. And then it will drain at a speed of 160 gallons per minute. So it's draining faster. So now the slope should be steeper. It should be greater. So now from here, this is where you open the second drain, the slope should be steeper. So you can draw that in there. Last example, Molly hits a golf ball in the air. Sketch a curve to show the height of the ball over time. So we're going to have height over time. So height over time. Now a golf ball, we see trajectory problems like this a lot in physics. It's not going to travel in a straight line, right? When you hit it into the air, it follows a curve. So we can kind of sketch that curve. You're going to hit it up into the air and it curves at the top and then comes back down. So that's generally going to be the trajectory of the golf ball. So we're going to try more of these in class. So study up and we'll see you in class. Have a great day.